In these questions, we're going to look at how to determine the longitude from shadow stick data. In the first question, Sandra has set up a simple shadow stick that creates the shortest shadow at 11:58 GMT. On the day that Sandra carried out her experiment, the equation of time was plus 8 minutes, and we need to determine Sandra's longitude. So the first thing that we're going to do is we're going to work out the mean solar time on the day that Sandra carried out her experiment. So to do that, we're going to do the equation of time equals the apparent solar time minus the mean solar time. Now we know that the equation of time was 8 minutes because it tells us that in the question. And we know the apparent solar time is going to be 12 o'clock because that would be the time that the shortest shadow was created. So to minus the mean solar time in that, we know that this therefore must be 11:52 because 11:52 take away from 12 leaves us plus 8 minutes. Now we also know that the time in GMT was 11:58. So if we work out the difference between the mean solar time at Sandra's location and the GMT, we're left with 6 minutes. So we know that the difference in time was 6 minutes. Now we then want to work this out into degrees of longitude to work out the difference. To do that, we're going to divide by 4 because 4 minutes is equivalent to 1 degree. So 6 divided by 4 gives us 1.5 degrees. So we know that Sandra was 1.5 degrees away from Greenwich. We then want to determine whether she's going to be east or west. The easiest way to think about this is that her mean solar time was 11:52, whereas it was 11:58 in Greenwich. So therefore she was earlier in the time than Greenwich, so she must be to the west. So therefore Sandra's longitude was 1.5 degrees west. We're going to use a very similar method for the next question. So Lucas used a simple shadow stick to find that the shortest shadow occurred at 12:01 GMT. On the day that Lucas carried out her experiment, the equation of time was minus 3 minutes. Determine Lucas's longitude. So again, we're going to use the equation of time equals the apparent solar time minus the mean solar time to work out our mean solar time. So this time we know that the equation of time was minus 3, that the apparent solar time was always 12 o'clock for a shadow stick experiment. That's the point when you get the lowest time. So therefore we know that the mean solar time must have been 12:03. We then want to work out the difference between mean solar time and GMT. So we're going to do 12:01 minus 12:03 to give us minus 2. And again, to work this out into degrees, so minus 2 minutes, we're going to divide by 4. So we know the difference is 0.5 degrees. So we know that the longitude was 0.5 degrees. Again, we want to work out if it's west or east. Again, we can see that from the negative, or if you wanted to think about it, you can see that while the time in was 12:01 in Greenwich, the mean solar time was 12:03, so they were later in the day, so therefore they must have been over to the east. The captain of a ship observes the sun and uses the equation of time for that day to calculate that the local mean time on a ship is 12:08. The ship carries an accurate clock that shows that GMT at that moment is 13:56. Determine the longitude of the ship. So again, we want to work out the difference between the ship's local mean time and the time in Greenwich, and we can see that that is 1 hour and 48 minutes. Again, we want to convert that into degrees. The easiest way to do that is to turn this into solely minutes. So 1 hour and 48 minutes is 108 minutes. We just do the 48 plus 60 minutes for an hour. And then again, we're going to divide that by 4 to turn the minutes into degrees. So we know that the difference is 27 degrees. Again, we can think about where it is. Well, it's later in the day at Greenwich, it's 13:56. It's earlier on the ship, so therefore it must be to the west of Greenwich. So the longitude is 27 degrees west. A ship has been sailing for some time, and on one particular day, the captain uses measurements of the sun's altitude to deduce that the local mean time is 12 noon. The ship carries an accurate clock that tells the captain that the time in Greenwich at the moment is 1:40 in the afternoon. Determine the longitude. So again, we want to work out the difference between the two locations. So 1:40 minus 12 is 1 hour and 40 minutes. and we're going to convert that into minutes. So that will be 100 minutes, as we do 60 for the hour plus 40. We're going to turn our minutes into degrees, so 100 divided by 4 equals 25 degrees. So we know that the difference in longitude is 25 degrees from Greenwich. And again, because it's earlier in the day, 12 noon, compared to afternoon in Greenwich, we know it's going to be to the west. And finally, the longitude of a ship is 36 degrees east on a day when the equation of time is 0. What is the time in London at the precise moment that the sun lies on the ship's local meridian? So we can use the equation of time equals apparent solar time minus mean solar time. Again, we probably don't need to do this, as you can see that when the equation of time is 0, it's not going to be a very exciting equation. So we know that the apparent solar time will be 12 when the sun lies on the ship's local meridian. So therefore the mean solar time must also be 12. But again, we could work this out differently if the equation of time wasn't 0. So we know that is 12 o'clock. Now we want to work out the time in GMT. So we know it's 36 degrees east. So we want to convert that into a time in minutes. So to do that, we're going to multiply it by 4. And if we do that, we find out it's 144 minutes difference in time between the ship's location and Greenwich. We then want to turn this into hours. It's just easier to work with. So if we think about it, 1 hour would be 60 minutes, 2 hours would be 120 minutes, 3 hours would be 180 minutes. So therefore we know it's 2 hours. And if 2 hours is 120 minutes, we've got 24 minutes left over. So there must be a 2 hour and 24 minute difference between the time on the ship and the time in Greenwich. Now, because the ship is to the east, therefore the ship is further ahead in time. It will be late in the day. So what we need to do is we need to minus 2 hours 24 minutes from 12 to get the time in Greenwich. So 12 o'clock minus 2 hours 24. So 12 minus the 2 will give us 10 o'clock. Minus the 24 minutes means that the time in Greenwich must be 9:36.